Hi everyone, welcome to this session by VLSI Deep Dive on using ChatGPT and AI for RTL design and verification. What we are going to talk about is, let me just move forward. Okay, so what we are going to talk about is how ChatGPT and other similar technologies are changing the world, what it means to the current and future workforce, especially in semiconductor and VLSI industry. We'll also talk about how to ensure your future jobs are future ready, and how you can use the emerging technologies as an ally. I am Vikas Sachdeva. I have written a book on how do you basically make sure your job is not taken away by AI, as an I will take some of the experts from that book. And we'll also go into some of the examples of how chat gpt you can use for rtl design and design verification as well. There is a slight caveat in terms of when you should be using it and when you should not be using it. I'll be also be talking about that. So let's get started. Let's first understand why we are here, right? Why these things are changing the world and why we are here. Just a minute. Yeah. So Chat GPT is basically something which is released by Microsoft in partnership with OpenAI. There are similar other platform like Bard from Google. So Chat GPT is a technology which basically you interact with this AI platform in a conversational way, which means as in like a chat. And we'll be going into how you can use it for RTL verification and also RTL design. And the advantage of this dialogue format, it makes possible for chat gpt to, you can ask some questions, then you can ask follow-up questions. If you make any mistakes, it can correct those mistakes, or you can ask any general question. So basically it's a conversational, like you're chatting with an artificial intelligence, and you can keep modifying your requirement accordingly. It will give answers. So and then we'll see some examples of that in RTL design. I will ask a chat gpt a platform to do something, then ask it to modify something, and you'll see it's kind of a conversational platform. Okay, so basically, typically previously the artificial intelligence technologies which used to exist was simply analyzing the existing data, classifying those data. For example, whether, let's say, if it's an image classification, whether it's a cat or a dog, right? These were the machine learning technology, machine learning analysis which used to exist. Now the new technologies which are coming up, like for example generative AI, which is known as generative AI, and ChatGPT is one kind of generative AI, is can sometimes create something entirely new. It can create text, as in you will see in some examples how it can create text. It can create images also, so it can be used by designers to create images also. It can create audio, and also in some cases it can actually create synthetic data. What is synthetic data? It can create new data as well. And across business, science, and society itself, it has a potential to enable groundbreaking human creativity and productivity. And one of the important thing to keep in mind is it's enabling in humans. It's not taking away human job, it's enabling humans. And I'll talk about a little bit more detail about how you can think of this enabling your job better rather than taking your job away. So let's go into a little bit more detail how it works. Okay, so basically what generative AI does is it has a variety of deep learning techniques, and we are not going into details of what those deep learning techniques are, as in I have a specific course on deep learning. If you want to learn more about deep learning and what is the hardware which is employed to do all these neural network, you can go and look into separate course that I have. Here, it's a high-level overview of what the generative AI does, right? As in, typically for a machine learning process, there is two aspects. First aspect is training, and this generative AI model is fed with a large set of data. Okay. And what when you feed it with large set of data, that allows it to learn the patterns, structures, and features of the data. And then, based upon that, it creates a model which has its internal parameters known as training. And using that, it can revolutionize, optimize its ability to generate realistic and novel output. So it's a simple, it's a neural network, not a simple neural network, very complicated neural network. But the basics of any neural network is you give it a data. Based upon that data, it will train its neural network and optimize it to generate a certain specific output. Now, once that training is done, a model is written out, and for ChatGPT, actually, it's very complex model. This generative model can generate then new data from the what it has learned already. We're not going into technical detail of this. Something you can look into. I have a specific course. You can go to www.vlsideepdive.com. You can get that course. And of course, based upon the output which that you're generating, the neural network can update its model. Based upon, you can say, okay, this is not a correct output, please give me a correct output. That itself then is used by a neural network to improve its learning, to improve its model, to so that it can generate new, more refined data. So it keeps improving as you interact with the neural network. That's one of the important aspects. This allows us to keep improving. So if you have simple algorithms or loop, whatever you have written, that's it, right? As in, it's not going to update itself. The beauty of neural network is once you interact with it, once you give it more data, once you correct the data, it will keep on improving. Okay, so some examples of how it can be used. There is a large language models like generative AI models, which are generated on massive data set. It can actually use for text summarization. So you can give ChatGPT a large amount of text and ask it to summarize. It can summarize that text as well. It can be used for translation. You can translate from one language to another if it has been trained to that. You can also use it for question and answering. So basically, you can ask it a question. For example, let's say, what is Verilog in RTL design, or you can ask how to basically have low power circuits. Based upon that, it can give answers. So there are multiple ways these generative AI models can be used. Large language model, which is to do conversations, summarization of text, translation from one language to another, and asking question and answering questions. So these are some of the ways these models can be used, and we'll use some examples of that. And if you can see, right, some of these examples will actually help you understand. Let's say if you're a student, you can ask questions, and most of the time, if it's not a like new technologies, it will have relevant data to answer those questions as well. Now the question which everyone is scared about is how it's gonna impact the world, right? So your synthetic media, what do you mean by synthetic media? As in, there are some small videos, small ad clippers which are created that will become a norm. As in, you can automatically create small videos or AI generated videos that will soon start becoming the norm. Like everyone will be using it. You will have AI powered work apps like which can help increase productivity. You can have, for example, if someone of you would have used Calendly, which can be used to set up a meeting with someone. It figures out from someone else's calendar what times these people are available. So it increases productivity. So this is one kind of app, but there are multiple kind of apps which can be combined together to increase human productivity. You will have AI search engines, as in you would have heard about Microsoft and integrating ChatGPT into their search engines. So with search engines right now, like when you have to search on Google, it will give you 10 pages. You have to go through those pages and figure out what is a relevant answer for you. This also will become much better and productive, as in you can directly get relevant answer. ChatGPT is one example of that. AI can help then create and run websites. It can help create apps. It will also help in online education, like I think, right? Talk to you about, right? I mean, you can ask questions, and AI can help answering those questions. So it will help in online education, game development, and you will start seeing chatbots will start appearing more and more. As in, you would be seeing chatbots appearing right now on a lot of websites, but this will start appearing more and more and start sounding more human like. So these are some of the impacts we'll see in the real world of AI. Now, how does that impact us? Let's talk about specifically VLSI field, our hardware design field, our semiconductor field. What is happening there? How it is changing the VLSI field? So these are some of the news clippets from last years that I have taken a screenshot and to explain how within the chip design industry, how AI is changing the world, right? As in, so one of the thing is Google basically is using AI to design its next generation of AI more quickly than what human can. As in, they basically did some sort of basically placement and route backend, and AI can suggest better placement strategies than like thinking about like typically when you do backend design, you will do multiple options of placements and then figure out which one is the right placement for your design. AI can learn from previous history and tell you for this kind of design what is the right placement strategy to be used. So this can then save multiple weeks of doing parallel runs and then just going by what AI is suggesting. So this is one of the ways where basically Google used it. And again, you can see, right, it's not taking human job away. It's basically enabling human to do a better job. Right? So then basically Synopsys is spending a lot of effort and R&D in artificial intelligence. They are creating artificial intelligence based EDA tools. So then again, basically they're helping in multiple aspects of the flow, whether it's synthesis, whether it's functional verification, formal verification. There are multiple techniques which are being used to improve the designer productivity. Again, it's not taking designers' job away, it's to improve designers' productivity. Similar to Google, NVIDIA is also using AI to improve its chip design. So there are multiple companies working, whether together or separately, to impact even the hardware design field as well. And it's the main goal of this has been to improve the chip designer productivity, people who design chips, their productivity. So specific areas where I would say I have seen it to be used, as in this is not an exhaustive list, but some examples of where AI is being used to improve your chip design. One, basically, Synopsys used this AI and ML to increase data center chip design. They were able to meet a faster frequency. They were able to meet timing in half the time, and basically they improved the designer productivity. So none of the engineer lost job, but they were able to improve the designer productivity. That helps get to the market faster, and of course going to market faster is very important aspect in basically chip design. Then I told, right, cadence use cadence software uses it for automated floor planning option using AI/ML. So what is automated floor planning option, right? Basically, when you're doing floor plan, as I say, right, placement and floor plan, there are multiple options which are available, and AI can help you decide better which is a better option for this kind of design, and that is what Cadence use to do automatic floor planning options. So this basically are part of EDA software and help improve designer productivity. Let's see some more examples. Now, there is a GitHub page I found during my research, which basically talks about there are multiple papers which have been done on using AI and machine learning for EDA applications. And these are some of the papers which I have mentioned. There are papers, as in this is the link. You can go to this link, ai4eda.github.io. You will find all these paper links to all these papers. And these papers talk about the work which has been done using machine learning to get basically using machine learning to improve designers' productivity. What are the areas where all this has been used? So one of the area is high level synthesis. High level synthesis is basically doing a synthesis from C to RTL. It's being used in logic synthesis, which is direct like synthesis from RTL to gate. It's actually been used in circuit verification. So there are papers, as in you can go to this website, AI for EDA github.io. You'll find all these link to all these papers where you can gain more understanding, gain more knowledge how AI is being used in these particular areas. This floor plan, placement, a lot of backend steps, clock tree synthesis, routing, timing and layout verification, mask verification. It's also being used in analog layout synthesis, one of which is one of the holy grail. It takes a lot of manual effort, a lot of designer effort to generate layouts. There are some techniques which have been used for analog layout synthesis as well. And this website has a list of all those papers. It's been used in testing. So these are some of the areas. If one of these areas is your interest area, you can go and look at those paper, and you can of course read. As in, if there is any paper you're not able to understand, I can help you out. You go to our website. There's a link to connect to me. You can go and connect to me if there is something more you want to understand about those papers. Now, another interesting thing which happened recently, one of the companies, efabulous.com, which is also supported by Google, they basically help you design chips with open source software. They did an AI design challenge. Okay. What is the AI design challenge? They asked people to write or create hardware design, chip design that is coded by AI. What is mean by coded by AI is basically you can use Bard, which is Google generative AI platform, or ChatGPT, which is Microsoft platform, and ask it, work with it, give it chat prompts to generate a Verilog code for your RTL design. The requirement for this challenge was that the RTL design should be done by AI, but the verification should be done yourself in traditional ways. The reason for this requirement was, even though AI is able to generate some level of RTL, as in if you give both verification and RTL to AI, maybe same mistake can be made, right? So at the end of the day, you want to make sure whatever RTL is written, it should be correctly verified. This is the reason why you have different RTL teams and verification team, right? One RTL team will write RTL and another verification team will verify it. So they wanted to keep those two things separate in a like it's done in our hardware design flow. Then basically your RTL is generated by AI, while verification is done by users, humans, and all basically you have to generate. They had to generate Verilog using these Chat GPT prompts, and those are the deliverables. The challenge is completed. There were 3 people who actually won. They were able to generate designs using ChatGPT, and you can go to their website efabulous.com. It has all the information about how that challenge was done, how and what are the designs that won this challenge. Some of those designs actually are going to be taped out and put it on the chips. Okay, so another area which is where it's gonna be helpful in VLSI, which VLSI deep dive is working on, is it can help simplify administrative tasks, as in it can help generate certificates, it can help generate questions, which quizzes, which we are going to use in our platform. It can generate some amount of smart content, as in some of our content now, which we put on LinkedIn, is being generated by ChatGPT. It can also help personalize your learning, specifically for VLSI. You can directly go to ChatGPT and ask your questions, and based upon your previous history, accordingly, it will answer the questions. So even for education, not in general for any kind of education, but also for specifically for VLSI education, where we are focused on, AI is going to be really helpful, and you'll start seeing some of those things appearing on our website and our learning platform as well. Okay, so let's go into the deep of the things, like what is, as in, just so that if some people are not aware of what is RTL design, I'll just spend a minute on it, and then we'll start using some prompts to generate RTL design. So RTL design, basically, as you understand, right, it's a representation of your hardware, typically done in languages like Verilog and VHDL. This is one VHDL example, where basically typically you will have inputs, you will have flops, registers, and there'll be combination logic in between. That's a typical RTL design structure which will be there. And RTL design typically is used to automatically then convert that into what is known as gate level design. A lot of At a lot of places now, right now, RTL design is still heavily and dominantly used. But what I've seen recently, a lot of RTL is not rewritten, as in just previous RTL is modified. In some, as in some, well, let's say 10% of the cases where actually you're writing your new RTL. So this RTL design, I've just talked about in a minute. I'm not going into detail, as in I'm assuming some of the people who are actually joining this know what an RTL design is. So now let's do something. Okay, let's try to use ChatGPT to create simple design, and I'm just using it as a demo. As in, of course, you can use it at a detail level, or the level you want to use. So let me just unshare my screen and move to sharing something else, which I'll be using for showing RTL design. Let me actually share my full screen. Just give me a second. Okay. Okay. If I'm sharing my screen again, and this is something you would have, I think most of the people who have started using Chat GPT at some level would have seen this screen. This is the opening chat window of the chat machine, right? So, and one of the thing that now I'll talk about is how it can be used in a conversational way. So what we'll do is we'll ask it to design a D flip flop, right? So let's do that. Let's Okay, let's see how it proceeds. So you can see, right, it has written a code for D flip flop. I asked it to write a code, Verilog code for D flip flop. You can see it has written out always at passage of clock or passage of reset. So it's writing a code which is basically, you can say, it's a flop, D flip flop, reset value of this is 0, and then output is Q equal to D. Of course, it's a basic example, but you understand, right? As in these are the typical things you'll write about. So let me, and it's a conversational engine, right? So you can say, okay, change it to active low reset. Let's see what it does. So this was an active high reset. I asked it to change it to active low reset. Okay. So now when I told this, it understood the context that I'm still talking about the D flip flop, which I had just asked it to create. And I asked to change to active low reset. So you see, right? Previously it has created this, which is pause edge of reset, which is active high reset. And now it has changed it to neg edge of reset. Of course, it changed the port names, but now it is active row reset. Let's say I want to say change the reset value to 1. So the reset value right now it had created was 0. So now previously reset value it had created was 0. Now it has changed the reset value to 1. So you can see, right, for simple cases, it's able to do conversational. It's still not a level where you'll be worried about your job, but it's very good for someone who is learning Verilog designs, learning basic examples of Verilog design. It's very simple, right? So let me say if it can do some change this code to VHDL. Let's say how good a job it does. So now what it has done is it has changed the same code which you had written in Verilog to VHDL. So let's see if the code same, active low reset, then there is reset value which is 1. So now let's see what the VHDL code it has written. Active low reset, right? If reset 0, reset value is 1. So it has correctly changed it to VHDL. So let's say I say change it to system value. And some of these prompts I've not tried earlier, so you might, as in it might still make a mistake, but let's go. So for basic thing, it's working pretty well, right? As in, let's see, let's try a slightly more complicated example rather than this. Let's say we ask it to write a Verilog code for barrel shifter. Let's see it's able to write that as or not. Okay, so it's a barrel shifter. So it has written a barrel shifter. You have input data, the amount of shift you wanted to change to, whether you're doing shift right or shift left. So basically, shift right, if it is shift right, you shift the data right. This is the right operator it has used. And this is the left operator. Now let's try to give it something more abstract. Okay. Change shift right input to shift left. Let's say we want our default to be shift left. Let's see whether it's able to modify that code or not. Okay, so it's able to modify even that code. Now, one thing you will notice is basically now you earlier your default input was shift right. Now your default input is shift left, right? So it's able to do that, right? Let's ask it to design even more complicated code. So one of the complicated code, like at least when you're learning about VLSI, is creating a divide by 3 logic, right? So let's say right divide by 3 clock. Let's see how it does that. So it's right using a counter. So you would expect it to use a counter. And one of the thing you will notice, it's also explaining the code at the bottom. So let's say there is a counter starts. What is the reset value of the counter? There is now anyone who would have done this, written this code, you know this code will not work without reset, right? Because the clock counter will become counter whenever writes, it will come here, counter equal to counter plus 1, it will become an X. So anyone who has written this code, really, you know it will not work without reset, but this code is being written out with it. So I am able to find one mistake that this code is not reset without reset. So it will not work. Now that I can say from my experience, right? But as in ChatGPT doesn't know that. And we'll talk about one specific thing, right? It's writing out all these code based upon the learning has done. But the learning can be done on bad code as well. The learning can also be done on the code which was actually incorrect. So you can't trust this blindly. So that is something you have to keep in mind. So let me see, okay? Can you add reset logic? Let's see it's able to understand that or not. Okay, so it has added reset. So it actually was able to understand our instructions. We said, okay, you add reset logic, it added a reset. So then counter becomes 0 at reset, and then basically the clock is generated. Okay, so I think this code may work well now. But you as in within our 5 minutes of the work, we have seen one of the example where it didn't work. As in it was not actually a code which would have worked. But as in so bit, as in it's still helping you write a good as in some amount of code which would have taken you a longer amount of time to write it. So it's definitely going to help you increase your productivity. Now, one thing to notice here is some of the companies actually are going to ban this, because one of the thing is, let's say if you copy this code, right, as in it allows you to copy this code. When you're copying this code, you don't know whose copyright it is, right? So a lot of companies are scared that way, that if it's someone else's copyright code and you're copying and using it, it will be a problem. Also, companies don't want you to put your code in ChatGPT because it will use it for its learning, but as in it may be that company's copyright code. So that's something it may be banned in some of the companies, but for educational purposes or for your home usage, you can still use it. But I think it might, as in there are some companies who have already banned it, and there's some companies who are going to ban it further. But let's move forward. Let's try to see if we can design even a slightly more complex logic, right? So let's say write an RTL code for 101 sequence detector. See whether it's able to do that or not. Okay. So it has written a code for sequence detector 101. There are clocks and inputs, and there is an output which says sequence was detected or not. So let's see how it works. So initially, it has automatically added reset. That's a good job. Now, initially 00, if data input is 1, I'll go to next state. So it goes to 01. Then there in the 01 state, it's a 101, right? So it's 1. Okay, yeah. If data is in 1, then again 1, and sequence detected is state 10. So it detects first, it is in 0. It detects if data in is 1, it will go to 01 state. But here it should have detected 0, right? So there seems to be some mistake it has generated. So if data in is 1, it goes to the next state, right? Which is wrong. It should detect 0. So I think there is a mistake here. So you can see, right? It's able to do some of the jobs, but you still have to use your judgment. And of course, you do have to do, as in, even if you just copy this code, you still have to do your verification. So it's good, but it's not at a like you can completely 100% trust the code it's writing. So let's see. So basically, you have to use your judgment even if you're using. Let's say. So what typically I have seen from my side is, if it's a code which is generally available, which is like has been written somewhere on Quora and other places which might have been used for learning, it's able to generate a decent amount of code. But if it's something outside that, it becomes that little bit, as in it becomes more mistakes are made in those codes. Let's try to see if let's give an even more complicated code. We may not be able to check it, but let's see whether it's able to create or not, right? So let's say I will ask it to write, let's say write a Verilog code for, let's say, APB controller, right? So what I am assuming is it may be able to write something, but it's very difficult to verify the code it would write out is correct or not, unless you really kind of go into detail of it. So basically, it has written out some code for APB controller. There is APBP enable address, so normal inputs you would see, and then some register it's writing value, APBPW data based upon that. So it seems to be writing some code, but whether it's a correct APB controller, once you do verification, you know. So just to summarize, okay, let me come back to the slides I was presenting and come back there. So basically, the idea is it's able to write some code at a decent level. What we'll also do is now look into whether it can write system Verilog verification assertions. Okay, so let me come back to my original screen. Just a minute. Okay, so what is design verification is, and then what I'll ask to do is how AI can actually help us, or whether how good AI is for design verification. So AI design verification is typically you will have RTL or what is known as DUT. There are multiple ways to verify it. You might write self-checking test benches. You might write assertions, which will be corresponding to your design. And then you'll measure, as in you will give some constraints or input or maybe random stimuli. And based upon that, you'll see how much of the design I have verified, which is known as functional coverage and code coverage. Those are the certain aspects you will check. I'm not going into detail of functional verification. There is a specific functional verification course which is available on our website www.vlsideepdive.com. But our goal today is to see how AI can help us doing this job. Okay. So what we'll do is we'll try to write some of these examples on AI. Okay. So let me come back again to our prompt, which you can see, and let's see how whether AI is help can help us out there. So we'll ask it to write a test bench for a counter. We'll ask it to do this request, which is basically your assertion based verification. We'll ask it to write certain assertions. So let's see how well it does. Okay, let's say write a. Okay, so let's see whether it's able to write a test bench for a counter or not. Okay, so let's see. So I asked it to write a test bench for a counter. Let's see what it has done. So it has instantiated our counter, assuming these are the values. It has created a clock signal, which seems correct. Initially, clock is given 0. Reset is given a value. Then reset is put to active low. Now the question is, it's assuming reset to be active high, which may be correct. And then after some times, it's saying finish. And just for stimulus, it's just writing out the count value. Okay, so let's see it's able to understand our thing at a higher level. Like, can you make it self testing? What is a self testing test benches? Where it will check its own value, what should be the expected value, and then compare those values. Okay, so it's able to understand that, right? So I asked it to make it self testing. So what it does was, what is the expected count values, and then based upon that, if it's not an expected value, it's able to write. So basic what do you call counter test bench, it's able to write. Okay, now let's see, let's use a specific system verilog assertions, and let's ask it to write. Okay, write system verilog assertion for, let's see it's able to write this or not. Okay, so I asked it to write a system verilog assertions for the condition every time request signal goes high, acknowledgement signal exactly arrives 3 clocks later. Okay, so you can see it has written, the syntax is a little odd, but it still does the job. So every time request goes high, 3 cycle later, acknowledgement should arrive. Now I'll ask it to change it. Okay, the it can come, rather than saying 3 cycles, 3 to 5 cycles later, can you modify the assertion? Okay, so it has so basically I said act can come from 3 to 5 cycle later. Can you modify the assertion? And it has modified the assertion. Now let us say disable the assertion, let's say any signal, right? When X is 5. Let's say it's able to modify that or not. Okay, so it has added that code, disable the assertion when X is high, or reset reset is there, then it's able to disable. So seemingly for basic assertions, it's able to do a good job of writing out the assertion. Now let us write a more complicated assertion. Let's say write a system verilog assertion Let me do that. So write a system verilog assertion that checks B always occurs after A. So B basically occurs after A unless C is asserted in the middle. So basically B should occur after A. We are not giving any number of cycles. B should occur after A. But if C is asserted in the middle, that then it should not happen. Let's see how it writes it. So basically during reset, it's disabling it. Now, so not of A until B and C. Okay, so it's able to write some assertion. I'm not sure this is the correct assertion. This seemingly looks like may not be 100% correct. So as in based upon my experience, what I've seen is as you start becoming more complicated, it stops. As in you will start seeing a lot of examples where it will actually not work. Okay, so now let me come back to the slides. What we have seen is basically we have seen cases where it can write Verilog, it can write system verilog assertions. So at some level, it's able to write the code. And of course, this code is learned. Writing this code is, as I said, right, as in for any neural network application, for any AI, it's learning based upon data which is provided. And no one is guaranteeing that that data which is provided is correct or incorrect. So it's somehow basically can sometimes write incorrect code. We saw the counter case where basically it has written the code without the reset. So for RTL designs and verification, it does work well, but for the category of design which are already well known how to write it, right? And even if it's not writing well, at a minimum, it is providing very good starting template for these designs, right? And a lot of time we basically are looking to write templates. So let's say we have to write input output ports, we have to write some basic Verilog code, which right now how a designer does, right? As in, let's say I will ask you to write a new Verilog code which is based upon a previous design. You will basically copy a previous design or copy that file and start editing it. So at that level, it's nothing different from a designer does. Rather than designer will copy and edit it, will take him 1 hour. Rather than that, it will take designer 5 minutes. So it's still helping increase the designer productivity, helping increase the work which designer. But can it become much more worse? And that is something we should be worried about, right? Is it going to take everyone's job away? Of course, not at this level, but if it's keep on improving, what are the things you guys should be doing so that your job is not taken away? And we'll talk a little bit about that, right? Will this AI is going to take our job away, right? So far from what I have seen, given the way it's behaving, you're RTL designer, you're a design verification engineer, job is not at risk. As in you see, right, within our 5 minutes, we saw a few mistakes it made. But the AI is gonna improve, right? As in its AI learns about with its mistakes when user provides a feedback on its mistake. So it's gonna improve. So it's not that it will stay at this level right now. So it's going to improve. How much it will improve, that time has to tell, and we'll see how much it is improved. But what we can do at our level, which will help make sure that your still job is future ready, right? So now I'll go a little bit more towards not towards VLSI, talk about more things in general you can do to make sure you are one step away, one step ahead of the AI curve, right? So I've written this book, as in my name is Vikas Sachdeva. I've written this book Become Irreplaceable. It talks about some 7 ingredients which can help you to save your job from AI invasion. And just to put it in perspective, this book does not talk about AI. It does not talk about AI technology. It talks about humans. It talks about which things which are unique to humans, things which are important for humans, things which are you can do to grow more. Okay. And one of the things I deeply believe is even though a lot of low level work will be done by AI and we will really actually help beneficial for us to do a low level work, but it's not going to take away if we stay at a higher level thinking, right? Now, I'll give you an example, right? A lot of people you would have seen, right? As in, when you used to go to a bank, there will be bank, there'll be people, bank tellers. You will fill a form, and they will give you cash, right? Which will they'll withdraw from your account, update you of their books, and give it to you, that cash, right? Now that has been replaced by an ATM, right? As in, you don't have to meet any person and go there. But does that mean banking jobs have gone away? Banking jobs actually have increased. Banking jobs, there are a lot of new banks which are enabled by technology coming in right now. So just because AI is able to do something does not mean your job is at risk. If we stay at a higher abstraction level, at a higher level, and keep improving ourselves, your job is not going to go away. I will just give you a few examples of few things as a summary from this book. If you want to read the full book, you of course can go to Amazon and get this book. And one of the example, my favorite example is, how does AI work? AI works on previous data, right? As in previously what has happened. So let's say there was this very famous tennis game between Nadal and Medvedev. This was the score in the third set, right? And people who are familiar with tennis, like one of the person has Nadal had lost two initial sets, 6-2 and 7-6, and he was about to like lose on a break point on this third in the third set. Now, if I ask AI to predict who is going to win, they will definitely say, okay, Nadal is going to lose, right? Because it has learned what has happened from previous history. There is very low probability of Nadal winning here. But surprise, what happened? As in, Nadal actually won that match. So, this is just to demonstrate AI is good for what has happened in previous history, and based upon that, making some inferences. But so far, I'm not saying AI to do magical things, think about what can happen in the future, use some creativity to create something new, which humans are able to do. This game, Nadal won even against all odds, which humans have a capability to do. And because of that, humans have reached space. They have designed the machines you see today. So that's one of the things to keep in mind is in terms of human potential. Then at a personal level, what you should be doing, right? And based upon my experience, based upon what I've talked to people, is one of the important thing to succeed in what I say, in at least in our field, VLSI field, you need two kind of learnings. Okay, you should have a high level view of a lot all the flow in the VLSI, which is what I call breadth. So basically, you should be having it something known as a T-shaped profile. What I mean by T-shaped profile is you should have a breadth from cross-discipline competence, as in you should have a breadth of, let's say, you should know all the VLSI flow, multiple aspects. At some level of depth, you should know each of those. Then in one particular field, you should have depth. This can be your physical design field, it can be DFT field, it can be RTL design field, it can be design verification field. If you have this kind of T-shaped profile, you will be very, very successful in VLSI field. And also, once you have depth and both high level breadth in certain fields, you are able to create something. You are able to creatively think something. You look at a lot of hardware startups which are coming up, because that's because of the expertise, T-shaped profile. They had put initial efforts in learning those things. Now they are able to think, okay, what products will work in the market. So very important to think of learning in this way. It will really help you succeed in any field, and especially in VLSI, because that's where my experience has been. Another thing is make consistent efforts, right? Consistency is one of the most important aspects in learning, right? And this just does not apply to learning, it applies to any field, right? As in, if you keep going to gym every day, no matter if you just work for 10 minutes or 15 minutes, it will help improve your body shape, right? So consistency is another important aspect which you should think about from learning point of view, since we're talking about learning. Now, another thing I will ask you to do is, and then you can do it uh, in your head, you don't have to answer it. Just read the following list of letters, as in I will keep on stay on this slide for a couple of minutes, and then close your eyes and just look at it for 10 seconds or maybe 1 minute, and then try to remember what are the letters you saw. Okay, so I'll just take a pause for 1 minute. Try, see, you can do this activity. Look at all the letters on the screen and see how many letters you are able to remember. So let me try to do that myself, and maybe I'm able to remember 4 or 5 letters. Now I will change it to something else, and let's repeat that activity again. Same task, it's actually the same set of letters. I've just rearranged it. Read this and see how many letters you are able to remember. As in, read this just once, close your eyes, and see how many letters you are able to remember. Now, I'm pretty sure you are able to remember more letters here than in the previous slide. And what is the reason for it, right? The reason for it, some of these words you know from your previous experience. And this is one of the beauty of human mind is, once you do something or learn something, it starts making higher level abstractions of that, right? As it starts making more sense of what you have learned, and then that allows you to create multiple new things. This is possibility of human mind. Whether AI can still do it or not, will be able to do that in future, but this is one of the beauty of the human mind, that once you get once you, because of your curiosity, you gain knowledge, and using that knowledge, then you are able to connect the dots and creatively create something. That's one of the beauty of the human mind, which will, in my opinion, will keep it always ahead of AI. So I'll be sharing the recording of this video. Try to do this exercise again, as in when I post the recorded, and then try to see, and that's one of the beautiful aspect of human mind. Now, another thing to keep in mind is, what AI is doing, what robot is doing is, it's using some rules to create some data. But whether it actually understands it, that's a more like philosophical question. But if it does not understand it, it cannot use it to the take it to the next level and create something more advanced. And that's again one of the thing I mentioned in the book. If you're really interested by these concepts, you can go and check out that book on Amazon, and it's actually not very highly priced. It's very cheap, so you can just go and check, and you can actually download a Kindle version as well if you like prefer to read on your digital devices. So use some of the examples, as in you can actually use AI as an ally to make yourself more productive. I've talked about some of the examples. You can search for the book I am talking about on Amazon. It's also, as in if you search for me on LinkedIn, Vikas Sachdeva, you'll be able to find the link to the book as well. Or you can just go to Amazon and search Become Irreplaceable. You will find this book. This will help you also grow and see what are the skills and how you can gain those skills and ingredients to make yourself irreplaceable by an AI.